Is your Whirlpool style dryer not heating up? Well, I'm Dustin with Parts Doctor, and in today's video, I'm going to show you a few troubleshooting tips and components that you can check yourself to get your dryer up and running again. But make sure you stay to the end because there's one component inside this dryer that a lot of people never think to check. Let's jump into it. Since we'll be opening the back of the dryer and testing components, you want to make sure that the dryer is disconnected from the power. So here we are at the rear of the appliance, and you can see that the back panel and then the console panel have both been removed, and that's so we can easily see inside the dryer. Before we start testing the components, let's talk a little bit about how a dryer actually operates. So an interesting thing to me is that a dryer actually sucks more than it blows. So obviously you know that air is blown out of here, but there is a blower wheel that's right here that blows air. And what that does is create a negative airspace within the dryer cabinet that sucks air in through here. So this is the heater box. So air is sucked in here, heated with the heating element that's right here. And it goes into the dryer drum, goes with the clothes, dries out the clothes, and then exits this way. This is our lint chute. So this is actually where the lint screen actually goes. And I can remove this quick. You can see that there's a hole right here that's on the back of the drum and a corresponding hole here. And this is where the lint screen plays its role in catching the lint. So air is leaving here, leaving the drum, and it's going through this chute, but it's going through this first so the lint is caught, hopefully. But sometimes some lint can escape, go past there, get caught up in here or around this blower wheel before the air actually moves out. So a lot of the issues that you have with the dryer are usually because airflow is poor and it causes components to heat up too much. Air is not circulating well, and that's usually what the cause is. So now that we have a better idea of how things work, let's jump into taking a look at each of the components and how to test them. So now that we have a general idea of how air moves through the dryer, we can understand a few of the components that go to making up that process. As we talked about, the heating element is down here, and it's this large piece. It's held in by two different screws, and this is actually where electricity is cycled through some tightly wound coils, and they heat up, and then the air passes over there, and then heats up and enters into the dryer. So the connection for that is down here, and it's also the connection for this high limit thermostat. The high limit thermostat is a safety thermostat that monitors the temperature of the heating element and turns off power to the heating element if it overheats. And so air travels through here, heats up, and then it goes past this other sensor here. This is a high limit cutoff fuse, and basically what this senses for is if this air gets too hot, it will blow this fuse, and that will kill the power to the heating element. So if you have an issue with this thermostat, then you would have the heating element possibly getting too hot, and maybe if the thermostat doesn't sense that it's too hot, it won't turn off the electricity to that, so heat will build up and get hotter and hotter and hotter, and it'll blow this. So on the other side of that, we kind of have a similar situation, but as the air leaves the drum, travels down here to the blower, and before it exits, you'll see that there's a couple components here. This is your cycling or operating thermostat, and it is the thermostat that controls the temperature of your dryer. It cycles the heating element on and off to maintain the correct temperature based on the dryer's temperature selection switch. There is a white cutoff fuse that will blow if the temperature exiting the drum gets too hot. Depending on the model dryer, this fuse can cause the dryer not to start, run, or not heat. On our specific model dryer, this would cause the dryer not to run. So we often suggest that people, if you have a bad fuse here, if your temperature got out of range, it's probably because there's a failed component next to it. So whether it be the heating element or the high limit thermostat, or maybe the cycling thermostat down there. So if you have an issue with any of these components, make sure your dryer has good airflow. The first thing that we'll test will be the heating element itself, and then also the high limit thermostat. So before we do that, we want to disconnect that. And before you disconnect any of these wires here, If you're not familiar with it, you might want to take a photo with your cell phone camera so you have some reference for reattaching the wires later on. So to remove these, we'll just simply pull on all three, and I like to tuck them back behind here. You see there's a wire nut already on this wire. That's because one of our videos we show you how to replace the heating element wire. So while you're looking at this, as you're disconnecting, you want to check to see if it's looked like it got hot, maybe melted or something. Then you can refer to our heating element replacement wire video that we'll link down below. So now to remove the thermostat, all we have to do is lightly pry the connector, pop that off like that. Set your multimeter to the continuity setting. When the multimeter beeps, there is continuity. Touch the testing probes to each terminal on the heating element. If you hear a beep, the heating element has continuity and it should be good. If it does not beep, there is no continuity and your heating element could be bad. The heating element can break if it gets too hot. Next, test the heating element for a short by placing a test probe on one of the terminals and the other on the metal housing of the element. If you hear a beep, you may have a short and your element should be replaced. After testing the heating element, you will need to test the high limit thermostat. Still using your multimeter with a continuity setting, touch one test probe to either side of the thermostat. If you hear a beep, your thermostat may be good, but check out our video where we test the opening and closing of a thermostat by heating it up. Moving up the heater box, we will see the high limit cutoff fuse right here connected with two red wires. Just simply disconnect both of those wires, and with your multimeter on the continuity setting, touch one probe to each terminal on the cutoff. You should have continuity. If there is no continuity, this component should be replaced. If you have a blown thermal fuse, always investigate for the cause of why the fuse blew. It could be a failed component like a thermostat or restricted airflow in the dryer. To test the operating thermostat, or sometimes known as the cycling thermostat, we'll do the same thing where we disconnect all of the wires, and if this is something that you're unfamiliar with, maybe snap a photo with your camera so you have it for reference later. We will set the multimeter to the continuity setting, and we will test the two silver terminals on the top and bottom for continuity there. Then for these inside gold colored ones, we'll change the multimeter to our ohm setting, and we'll go from side to side here, and you're looking for a number between 7 and 10,000 ohms. If you get continuity between the top and the bottom, and you do get an ohms reading in between those two in the middle, then the operating or cycling thermostat should be good. If the cycling thermostat tests good, it can still be faulty because it may not be opening and closing at the proper temperature. You can check out our other video that shows how to test in further depth. If you continue to blow the white fuse above the cycling thermostat, we recommend to replace the cycling thermostat and check the dryer for proper airflow. And now we'll test this cutoff fuse right here. Disconnecting the two wires. Using the continuity setting, we'll go from each side, and as long as there's continuity there, this cutoff should still be good. So maybe you've tested all the components in the back of your dryer and you're not seeing anything that would cause it to not heat up. Well, one of the issues might actually be the power that's coming into your appliance. So a normal dryer takes 240 volts of electricity, which is about double what a normal outlet is. So the easiest way to describe it would be that you have 110 to 120 volts coming in this side and this side. And oftentimes if there is an issue with your outlet or your cord not connecting, then one side of the dryer on this side could still operate everything except for the heating element, while this side of the terminal block is what powers the actual heating element. So if you are seeing normal dryer operation, the light comes on, the drum is spinning, but it's not creating heat, one of the issues could be the power that's coming in. So on this side of the terminal block is usually where the heating element is powered from. So you want to take a look at those terminals, you want to take a look at the connections, make sure everything is tight, and then make sure that the outlet is actually producing enough power to power your dryer. Sometimes your dryer not heating up could actually be a problem within the timer itself. Inside the timer, there's little arms and connectors that tell the heating element when to go on and off, and so those can sometimes get dirty or arced inside of there and not make a proper connection, which would then not tell the heating element to turn on. So we have a whole video on how you can test your timer and things to look for there, but that could also be an issue as to why your dryer is not heating up. So you've tested all the components on the back of the dryer, including the terminal block, the power supply, and even the timer, but you're still not getting heat to the dryer. One thing that you can check is inside the cabinet there's a drive motor. And that drive motor is responsible for turning the drum of the dryer as well as this blower fan down here. If that drive motor stops spinning, the centrifugal switch that's on the motor will not trigger, and that will cause the heating element not to turn on. Because if the motor's not turning, the blower fan's not turning, so that means the air is not circulating through the dryer, so that means that things can heat up and become a potential fire hazard. Well, that's all for today's video. I hope you're able to figure out why your dryer is not heating up. Remember, a big takeaway from this video is that airflow is so crucial to your dryer's performance. If air cannot enter or exit the machine in an effective manner, components are going to overheat and fail more often than they should. Whirlpool recommends you take out your lint screen and clean it with soap and water every 6 months. They also recommend that you check your exhaust vent, the exhaust duct to your house, and inside the lint chute every 2 years to make sure that there's no blockages. As always, I'm Dustin with Parts Doctor. Until next time, thanks for watching, and we'll see you later.